question number 10, we're going to be using the de Broglie wave equation to calculate some values. So for the first question, we need to calculate the wavelength of a 70 kilogram person traveling at 6 miles per hour. With all mathematical questions, we always want to make sure that the units are correct before we do any calculations. So miles per hour is not the units that we want. We want to have meters per second. So we can convert the units using dimensional analysis. So 6 miles per hour times 1 hour is equal to 3,600 seconds, and 1 mile is equal to 1,600 meters. It will be useful to memorize these conversions. Using our calculator, we will get 2.67 meters per second. Now we have all the information that we need to calculate the wavelength for question 1. So we have Planck's constant, 6.63 times 10 to the negative 34 joules times seconds, over the mass, 70 kilograms, which is what we want it in, and times 2.67 meters per second. Now you may ask, how do we get from joules times seconds over kilograms times meters per second? How do we get meters, which is what are the units for wavelength? So let's just do a quick check. So joules equals kilogram times meters squared over seconds squared. Therefore, if we do kilogram per meter times meters squared over seconds squared times seconds here in Planck's constant divided by kilogram times meter per second, we see that the kilograms cross out, the seconds also cross out, and we're left with 1 meter. Therefore, just using our calculator, we will get 3.6 times 10 to the negative 36 meter. For problem B, we need to calculate the velocity of an electron with a particular wavelength. So we need to reorganize our de Broglie wave equation. We will get that the velocity equals Planck's constant over mass times the wavelength. Now, the wavelength is not in the correct units. We need to convert picometers to meters. So again, using dimensional analysis, we can do 450 picometers times, 1 picometer equals 10 to the minus 12 meters. Make sure not to put 10 to the 12 meters. Students often make the mistake. So make sure that, because the picometer is smaller, so it's 10 to the minus 12 meters. Therefore, we have 450 times 10 to the negative 12 meters. Now we have all the information we need to calculate this problem. So we'll have velocity equals 6.63 times 10 to the negative 34 joule per second over the mass, which is 9.1 times 10 to the negative 31 kilograms times 450 times 10 to the negative 12 meters. So like in question A, you can check to make sure that the units will cancel out, but here I'll just show that with joules, all these will cross out and we'll be left with meters per second. Therefore, we will be left with the answer 1.6 times 10 to the 6 meters per second. Now for question C, we need to reorganize our de Broglie wave equation again. Because now we need to calculate the mass. Therefore, we'll be left with mass equals h over v times the wavelength. Now, the units again are in the of the wavelength are incorrect. We need to convert nanometers to meters. So again, we can use dimensional analysis, and we will get 1 nanometer is 10 to the minus 9 meters. Okay, so 12 times 10 to the 9. Oh, make sure the negative 9 meters. So now we have all the information we need, so we can do meters equals Planck's constant. And the velocity is the speed of light. So remember that is 3 times 10 to the 8th meters per second times 12 times 10 to the negative 9 meters. Also Planck's constant, remember to include the units. And here we can just check the units to make sure, like before. So joules equals kilogram per times meters squared over seconds squared, multiplied by seconds here, over meters per second times meter. So the meters cross out, and the seconds also cross out, and we're left with kilogram, the mass. So if we calculate using our calculator, we'll get 1.8 times 10 to the 34 minus 34 kilogram.